Hi everybody, it's Miss Austin. I'm going to be doing the Unit 4 Lesson 6 practice problems. You might be doing them on Desmos or you might be doing them in your book. Here we go. Today we learned the names for these ratios we've been looking at in tables, and I'm just going to write them down on the top of my paper. The sine of an angle is the ratio of the opposite being divided by the hypotenuse. The cosine of an angle is the ratio of the adjacent side being divided by the hypotenuse. And the tangent of an angle is when you take the opposite side and divide it by the adjacent. Okay? All right, select all statements that are true. So it says sine of theta, let's put our finger on theta, is 4, that's the opposite, divided by the square root of 97. That's the hypotenuse. Opposite over hypotenuse. Yes. Tangent of beta, here's beta, is 9, that's the opposite, divided by the adjacent. Is that correct? Yep, opposite divided by adjacent. The tangent of beta is 4, that's the adjacent, divided by 9, which is the opposite. No, for tangent it has to be the opposite side on top, divided by the adjacent on the bottom. That is incorrect. Cosine of beta is 4 adjacent divided by square root of 97, which is the hypotenuse. Yes, adjacent divided by the hypotenuse. And then the last one, instead of looking at the trig ratios, it's asking us if 4 squared plus 9 squared is this leg squared plus this leg squared equal to 97. Well, wait, what happened to the square root symbol? Let's look at this. The legs squared and added up should equal the hypotenuse squared. But squaring is the inverse of square root, so technically that would wipe that out. So that is true. Yes. Number 2, write an expression that can be used to find the length of JH, and then write one that can be used to find GJ. So let's start with this one. Well, I want that one. Let's use 35 because that's the one they gave me. What's that? That's the opposite. And they gave me the hypotenuse. Which trig function uses opposite and hypotenuse? Sine. So to find this, if I was going to find it, to find this side, I'm just going to call it JH. The sine of 35 is JH divided by 9. And if I had to solve that, it didn't ask me to, right? If I'm trying to get that alone, I'd multiply both sides by 9 because that ratio is stored in my calculator. Okay, how about GJ right here? Well, if I'm using 35, now we're talking about the adjacent side. So I would need to use the adjacent and then that one they gave me, the hypotenuse. Which trig function uses the adjacent and the hypotenuse? Cosine. So cosine of 35 equals, I don't know, I'm calling it GJ over 9. Number 3, Andre and Claire are discussing triangle ABC that has right angle at C and a hypotenuse of 15. Andre thinks the triangle could have legs of 9 and 12. So let's draw this out. So right triangle at C, hypotenuse of 15, and Andre says he thinks it can have legs of 9 and 12. Claire, I'll draw her example. Claire thinks that B, let's call this one B, could be 20 degrees and BC would be 14.1. Okay, well, let's try. So for Andres, he's just saying that 9 squared plus 12 squared would make 15 squared. That would have to be true, right? Let's test it out. Is 9 squared plus 12 squared equal to 15 squared? Let's see. 9 squared plus 12 squared is 225. equals, that better be 225. 15 squared. Yep. Andre is correct. Now, does it necessarily mean Claire is wrong? No, we better go check. Claire is not using the idea of Pythagorean theorem. She's using the idea of these ratios of side lengths, right? So let's see, what do I have here? I have the adjacent. And why am I using 20? Because they gave me that. They gave me the angle 20. So that's my adjacent side, and that's my hypotenuse. So the adjacent divided by the hypotenuse is 14.1 divided by 15 is 0.94, right? So now let's see, if we didn't know this, let's use this angle and see if using, right, adjacent over hypotenuse would be the cosine. So is the cosine of 20 should be the adjacent, I'll say I don't know, over 15. I'm going to pretend I don't know that it's 14.1, okay? But I should get 0.94. Let's see. So if I multiply this side by 15, multiply this side by 15, use my calculator. 15 times the cos, whoops, I did 115. 15 times the cos of 20. You know what? This calculator's in the wrong mode. Oopsie daisy. The cos 15 times the cos of 20, 14.1. Oops, sorry, I don't know why I hit that. Yep. So using the trig function on my calculator, using cosine of 20, and pretending I didn't know what that was, it does come out to be 14.1. And 14.1 divided by 15, yep, it works too. All right, moving on. A triangle has side lengths 5, 12, and 13. Verify that it's a Pythagorean triple. So I like to have a picture 5, 12, 13. If this is a Pythagorean triple, then the legs squared added up should equal the hypotenuse squared. 5 squared plus 12 squared is 169. 13 squared, 169. Yes. Approximate the acute angles. Well, I think they're wanting us to use a table here. So let's just go for this angle right here. I'll call it theta. If I wanted this angle, I can use any of the sides. I'm just going to do the opposite divided by the hypotenuse. So this angle, if I take the opposite and divide it by the hypotenuse, so if I take 5 divided by 13, eventually we're going to learn how to use the calculator to do this, but it's about 0.385. So I've got to go get my trig table. 0.3, and I did the opposite divided by the hypotenuse, so around here 0.385. 0.34 is 20, so I'd say just maybe a little bit. I'm going to say 23 degrees. So 23 degrees. Now if that's 23, these two, right, they got to add up to 90. So what's 90 minus 23? 67. Okay. Number 5, approximate the angles that have the following quotient. So we're just going to use our table over and over. the adjacent divided by the hypotenuse of 0.966. I mean, that looks like it's almost right in between there. I'm going to say about 15 degrees. Opposite divided by the hypotenuse of 0.46. That's closer to 30, right? It's closer to 0.5, so I'm going to say 27. Maybe 28. We're just approximating. Adjacent divided by hypotenuse of 0.30. I would say, I don't know. Oh, it's going to be maybe 70. Oh, smaller than 0.30. Okay, come on, Miss Austin. So maybe 70.25 would be 75. I don't know, 74. Opposite divided by adjacent, 1.036 would be somewhere between these two, 40 and 50. 1.036, 45. Right? And eventually, we are going to learn how to use the calculator to find these exactly instead of making approximates. Lynn missed class and Tyler is trying to help her use the table to approximate the angle measures that have the ratio listed. You can use the right triangle table to figure this out. Lynn notices that some of the ratios are the same in each row. Estimate the angles and explain why some of the values are repeated. So let's go look for the adjacent divided by the hypotenuse of 0.57. I'm going to say 55 because it's right in there. Now, remember, if I was on a triangle and it had an angle of 55, draw a quick picture, the other angle is going to be 35, right? And when I use this angle, the opposite side, right? But if I go over to this angle, that opposite side became my adjacent side. So anytime when you're in a table, two angles that are complementary, meaning they add up to 90, these values are just switched. So I know this is 35. Any two, it could be 50 and 40, 20 and 70. If they add up to 90, it means they're part of the same right triangle. And the answer when you take the opposite divided by the hypotenuse, if you switch over to that angle, that becomes the answer when you take the adjacent divided by the hypotenuse. That's why those are switching. Okay? All right, last one. Number 7. Find the length of each leg. So now they gave us all the angles this time. So, and we're going to use trig to find the answer here. So I'm going to use 60. So if I'm going to call this one X and I'll call this one Y. So what do we got? This is my adjacent and this is my hypotenuse. Which trig function uses adjacent and hypotenuse? Cosine. So the cosine of 60 is the adjacent, which is the I don't know, over the hypotenuse. I'm trying to figure out what X is. How would I get X alone? It's being divided by 4. I'm going to multiply by 4. Whatever I do to one side, I do to the other. Those are going to cancel. I'm going to go to my calculator. 4 times the cosine of 60. The missing side is 2. Okay, now let's figure out Y. I'm still going to use 60. You can use 30. It doesn't matter, right? So that's my opposite. And I'm going to use this one they gave me, my hypotenuse. Opposite over hypotenuse is sine. So the sine of 60 is the opposite, which I don't know, I'm calling it Y, over the hypotenuse, which is 4. Trying to get Y alone, figure out what it is. It's being divided by 4. I'm going to multiply by 4. Whatever I do to one side, I do to the other. Remember, this is just those answers, or the ratios, stored in your calculator. 4 times, somebody programmed into your calculator the opposite divided by the hypotenuse. So you don't have to go look at the table. 4 times the sine of 60, approximately 3.46. Okay, and we are not going to do 8. I hope that helped, and I'll see you soon.